In the previous video, we worked with Spring Data JPA to fetch data as a JSON. In this video, we will do much more with Spring Data JPA, like adding, editing, deleting data from the front end, which we are going to build using Bootstrap and Thymeleaf. And as a bonus, I'll show you how to convert a simple HTML table into a data table, which allows searching, sorting, pagination, etc. Check out my previous videos in this series to catch up on what we have done till now in this project. It will make it easier to follow along. What we have right now in our Spring Boot application is an index.html and a couple of APIs to retrieve data from the database. So first up, I want to create a simple home page with links to pages showing all categories and question answers in a tabular format. Before that, I'll rename the question bank controller as question bank UI controller. Also, the index.html will be served up on the default path instead of the /index path. Let's open up our index.html. We are going to design this page with the help of Bootstrap. Bootstrap is the most popular HTML, CSS and JavaScript open source framework that you can use to quickly design and create responsive websites. Bootstrap saves us time by reducing the need to write a lot of CSS and JavaScript code. It is customizable and it is well documented. Bootstrap's grid system provides an elegant way to create mobile-first responsive layouts. To add Bootstrap, just copy-paste this style sheet link into the head of the HTML. In the body of the HTML, we will add a div tag and add Bootstrap classes like Jumbotron. A Jumbotron indicates a big gray box calling for special attention onto a specific content. We will also add a couple of more utility classes to add margin. In the notation MX5, M stands for margin. X indicates that the margins are to be added in the x-axis and the number 5 indicates the size of the margin. Align the div to the center and then add h2 tag for a level 2 heading. We will add two containers below that. In Bootstrap, a container is used to set the content's margins dealing with the responsive behavior of our layout. Inside these containers, we are going to add hyperlinks designed like buttons with the help of Bootstrap classes like btn, btn-dark, and make it a large button using btn-lg, and add a margin on the y-axis. Add the href attribute which specifies the URL to go to when the hyperlink is clicked. We will provide it as category. For now, it is just a placeholder since we have not added any request mapping for the path/category on our UI controller class. Label the hyperlink as show all categories. Do the same for question answers container as well with the href as questions. Let's run this application. On the localhost 8080, you can see the new index.html getting rendered which has a Jumbotron, the big grey box encompassing the two large buttons. If we click on show all categories, it returns a 404 page down font because we have not added any mapping for /category or /questions path. So let's add that in our controller. Add a get mapping for /category path and the method should return a HTML view name. Here I'll name it as category itself. Similarly, add a get mapping for /questions path and return the view name as questions. Now the Thymeleaf view resolver would look into the templates folder under resources for HTML files with the name category and questions. So let's create the corresponding category HTML and questions HTML. In the category HTML, provide the title as categories. The purpose of this HTML is to show the categories table from the database in a tabular format. The Spring Web MVC framework provides model view controller architecture and is designed around a dispatcher servlet that dispatches requests to handlers. The model interface acts as a data container that contains the data of the MVC application and is used to transfer data between the controller and the view. That is, the HTML views are populated using the model object passed to it with the help of templating engine like Thymeleaf. So in our request mapping method, we just need to add model as an argument and Spring supplies this object to the method in the runtime. The model is a map interface that defines a holder for model attributes. The attribute can be a string or an object or a connection. Let's add an attribute with the name categories and its value should be the list of category objects which we fetch from the database. To fetch the categories from the database, we will make use of the existing question bank service and inject it into this controller by using the auto-while annotation. Now we can call the fetch all categories method from the question bank service to fetch the list of categories from the table. Do the same for questions by adding an attribute with the name questions, and its value is fetched from the fetch all question answers method in question bank service. All the data we place within these models needs to be used by the HTML to render the web page. That is where Thymeleaf comes in. So in our category HTML, we will add the Thymeleaf namespace with the prefix th. Inside the body, we will add a HTML table. Under the table, add thead, the tag which is used to group header content. We will create 5 table headers using the th tag corresponding to the columns in our database's category table. To populate the table body, we can make use of Thymeleaf's standard expression syntax. To access the model attribute, we use the $curly braces. Since the categories added to the model is a list, we can iterate through the list using the th each iterating attribute. Much like the for each loop in Java, the th each attribute iterates over the categories, assigning each element to the variable name category. We can use the th-text attribute to evaluate its value expression and populate the body of the tag that it is in. We can access each attribute of the category object using the variable expression syntax and populate the rows. Run the application to see how it looks now in the browser. Click on the Show All Categories hyperlink and it redirects us to /category, which displays the records from the category table in our Postgres database in a tabular format. The table doesn't look bad, but it doesn't look great either. Next step is to beautify the table. The timestamp format is too bulky for my liking, so I'll show you how to format the timestamp using Thymeleaf. To format Java 8 Time API objects, we need to add Thymeleaf extras module as a dependency in our pom.xml. This module adds a temperance object allowing the formatting and creation of Java time objects from Thymeleaf templates. To format the local datetime object created timestamp, use the syntax temperance.format, the variable name, and the format you wish to have inside the standard expression. Similarly for the last updated timestamp as well. Bootstrap offers a number of opt-in styling options for tables. So we need to add the base CSS class table to the HTML table. Use table stripe to add zebra striping to any table row within the t-body. Add table bordered for borders on all sides of the table and cells. Add table hover to enable a hover state on table rows within a t-body. To make the table head appear dark gray, use the modifier class theadDark. We can make use of Thymeleaf conditionals to do null check on the categories attribute and display appropriate error messages. Here we will use Thymeleaf's switch case statements to do the null check. If categories object is null, then we just print out no categories. For any other case indicated by the star symbol, we will render the table. Replicate the same process in questions HTML. You can notice that the question answers class has category class as a property. We can access the properties of the category object using question.category.property name. We will display the category as a concatenation of subject and exam type with a hyphen in between. Add the Bootstrap CSS style sheet link in both the HTMLs. Run the application. We can see the styling applied on the table with dark table head and striped table body and a hover state on the table rows. The table is bordered. You can also notice that the timestamps are formatted according to the format we provided using the temporal object. We are now able to view the table from our front end. Next, we will see how to add new question answers and categories from the front end. So let's add 2 buttons in questions HTML, one button to add new question answer and another button to take us back to the home page. We will place these buttons inside a fluid container above the table. Inside the container, we will add a row div so that both the buttons are vertically aligned in this HTML. Add a column div inside the row which has a hyperlink to the home page, which is the default /path. This hyperlink will be styled as a dark button. Then we will add font awesome classes to add a home icon. Pull the home icon column to the left using the pull left class. Add another column div for the add new button and pull it to the right of the row so that we have the home icon to the left and the add new button to the right. Inside the column div, introduce a HTML form with the method post and THAction attribute to direct the form submission to post to the /question/add path. You can notice that the expression uses curly braces, which is the link expression syntax. Inside the form, we will have a button of type submit and is styled as a dark button using the font awesome icon for plus sign to the left of the text add new. We have added a custom CSS class add new to our button, which we can define in the head section using the style tag and assign appropriate properties and values. We will also override some of the button's properties. For using the font awesome icons in our HTML, we have to add the font awesome CSS to the head of our HTML. We will add the same buttons on the categories HTML. The add new button will post to the /category/add path. We need to add request mappings for both category/add and question/add paths. These forms are using post method and hence the mapping should be post mapping. We have added add category method for the /category/add path, which returns a view name add category, and add question method, which returns a add question view name. So now we need to add the corresponding HTML files in the templates folder. For now, I'll populate it with dummy content. Let's run this application to see how it behaves now. Click on show all categories and we can see the home button on the left and add new button on the right. Clicking on the home button takes us back to the index.html and the add new button takes us to the /category/add path, which returns the add category HTML with dummy content. We can check out the add new button on the questions page and it redirects to the add questions HTML. In the add category HTML, we are going to have a form where the user can input exam type and subject and click a submit button to add this new category to the backend table. Since we are going to make use of Bootstrap classes in this HTML, let's add the Bootstrap style sheet to the head. Inside the body, add a div aligned to the center, inside which we will have a level 2 heading add category. Below that, we will add a form which posts to the /category/save path and we are going to style it as a jumbotron. Inside the form, we will have two row divs marked as form group, which provides proper grouping of labels and inputs and form validation messages. We will add a label for the subject input with a bold font. We will add an input inside a div with the class form control, which is used to style input elements like input, select, text area. We will also add the required annotation, which specifies that this field must be filled out before submitting the form. In Spring Web MVC model, we can represent the form state using a single object called command object, which is a Java object that gets populated with the data from your form in the browser. Thymeleaf requires you to specify the command object using a THObject attribute in your form tag. This command object needs to be provided by the control method that rendered this view template. So let's make use of the Spring MVC model object to add a new category object to the model as an attribute. THObject attribute will be used to specify this model attribute object in the form. This form backing bean attached to the form contains all properties related to input fields. We can bind an input field to a property in the bean class using the THField attribute. We can use the selection expressions to bind the input value to the beans property. Selection expressions are similar to variable expressions except that they will be executed on a previously selected object instead of the whole context variables map. Hence, we just need to mention the property name subject in THField instead of category.subject. Next, we will create a button of type submit inside a div below the input divs and align it to the center of the jumbotron and label it as add. So on clicking this button, the form will be submitted to /category/save path. We will add a cancel button to its right, which is basically a hyperlink. We can use the back method of history object, which loads the previous URL in the browser history This form posts to /category/save path, and hence we need to add a post mapping for this path in our controller. To receive the form backing bean in our controller, add a method argument of type category and annotate it as model attribute, which binds the category form object's data with this category bean. The objective of this save category method is to save the form data in the category table and redirect to the categories page. For the controller to talk to the data layer, we need service layer's help. So we will use the question bank service and define a method save category inside the service interface with the category bean as the method parameter. We will implement this method in the service implementation, and we will use category repositories save method to persist the category bean in the database, since this category bean is itself a JPA entity. Once the entity is persisted, we will not return a view name, but we will redirect to the /category path using the redirect prefix. That is, on clicking add button on the add category page, the request reaches the /category/save path, which persists the data in the database and redirects the request to the /category path, which will be handled by the show all categories method. In the category HTML, I missed out the method attribute in the form, so let me add that. There is a typo on the cancel href. Let's run the application. Clicking on the add new button in categories page takes us to the add category page where we have a form to input subject and exam type. Both the fields are marked as required, and hence if we try to add without filling either, an alert is thrown to ask you to fill out the mandatory fields. On clicking the add button, the request goes to the /category/save path, which after persisting the new category in the table, redirects to the show all categories, which now shows the new entry in the table. You can see that the category ID is generated with an auto increment value since we annotated the category ID in the JPA entity with ID annotation and generated value annotation. Similarly, the created and last updated timestamps are generated automatically since they are annotated as creation timestamp and update timestamp respectively. In the same manner, let's populate the add question HTML as well. I have prepared the add question HTML similar to the add category HTML with a few changes, and also the corresponding request mapping methods in the controller. Let's go over them one by one. The basic structure remains the same. We have a form with inputs and 2 buttons, an add button to submit the form, and a cancel button to go back to the previous page. The question and answer inputs are text inputs, which are similar to the inputs we saw in the add category page. We can see the category input has a select tag, which is used for drop-downs. The value we select from this drop-down will be assigned to the category ID of the category object inside the question answers model object, which we assign to the form. This drop-down is populated using the model attribute categories, which is a list of category objects, which we injected to this view from the controller method by fetching all categories from the backend table. The select options are populated by iterating over each category object in the list using each attribute of Thymeleaf. The selected value will be the category ID. The text attribute is used to assign the label, which we will display in the dropdown. In our case, we will display subject-exam type as the category. When we select any of the category from the dropdown, the corresponding category ID will be assigned to the field category.category ID of the Q1 object. The Q1 object is a model attribute injected into this view from the add question method. Save question method in the controller is invoked on submitting the form in add question HTML, which in turn invokes a save question method in the question bank service, which will persist the form data into the table. Once done, the page will be redirected to /questions path, which will display all the question answers entries from the table. Let's run and see if it works. The add question page has a copy paste error on the heading. Please ignore it. We can see the categories are populated in the drop-down list. Let's fill out the entire form and add. The new entry is added to the top of the table, so the data is getting persisted. But I would like this list to be sorted by the question ID when displaying it in the table. For getting a sorted list from the database, we need to use order by keyword in our JPA repositories query method, which we discussed in the previous Spring Data JPA video. Let's define a query method in our question answers repository interface, which returns a list of question answers entities, and the method name will be findAll by order by question ID. Spring will provide the implementation for this method in the runtime by resolving this method name into the appropriate SQL query. And in the question bank service, we will use the newly defined custom query method instead of the default findAll method. Run the application. and the question answers table, the rows are now sorted by the question ID. We have built the add functionality. We now need to add both edit and delete functionality as well. I'll place two buttons on each row in the table to edit or delete rows. To do that, I'll add a column header actions, add a cell to the rightmost of the existing row. Inside the cell, I'll add a row div so that the buttons are present in the same row. Inside the div, I'll add a form post to the path /question/edit. The form will have a submit button and a hidden input question ID. We need this hidden input because unlike the add page, where the input are initially blank, in the edit question HTML, we need to populate the existing field value in the form, which then can be changed and updated. To fetch the current record in the edit page, we need to pass the question ID as a hidden field in the form post. The edit button will just have an icon which we are importing from the Google's material icon CSS. Similarly, for the delete button also, we will create a form to post to the /question/delete path. This will also have the question ID as hidden input and the corresponding material icon for delete. To delete the form, we will add a confirmation pop-up on click by using the onSubmit attribute, which will be invoked when the delete icon is clicked. On submit, we use a JavaScript statement which shows a modal window to confirm the delete operation. If you press cancel, the operation will be cancelled. If OK is pressed, the form gets submitted. Copy this new column out of the category HTML as well and change the corresponding paths to /category paths. And the hidden input in this case would be the category ID. Deleting a category will have a cascading effect on question answers table because of the foreign key relation. That is, if we delete a category, all question answers of that particular category will also get deleted. Change the alert message to reflect that warning. Now we need to create corresponding request mapping methods for /question/edit and /question/delete for handling the form requests. Unlike the form backing being we used in the previous form, in this form we are using hidden input. To read the form input and bind it to a parameter in our post mapping method, we can make use of the request param annotation. For deleting a question answer based on the question ID, we create delete question method in the service, which takes in the question ID as the parameter. In the service implementation, we can use the question answers JPA repository and make use of its default delete by ID method to delete the row in the table. The ID is an integer in the JPA entity and the database table. So we need to convert the string ID we got from the form to integer using integer.value of method. Once the deletion operation is completed, the post mapping method will redirect to the show all questions page. Create a delete category method similar to the delete question method. Change the request param name and variable. Create the corresponding delete methods in the service layer as well. And use the JPA repository to delete the record by using the category ID. We have created the mappings for delete. Let us now create the post mapping methods for edit. Edit category method will take in category ID as the request param and use the category ID to fetch the category entity from the table using the find by ID method of category repository, and then add it as a model attribute which will be passed to the view edit category HTML. The edit category HTML is very similar to add category HTML. The Thymeleaf fields hold on to the model attribute values we got from the edit category method. So in the edit category form page, the input fields will be pre-populated with the values we fetched from the database for the category ID. The submit button is labeled as update. The form action will be /category/save path, which is same as add category. The JPA repository's save method can handle both record creation and record updation. That is, if the ID is not present in the table, a new row will be created, and if the ID is already present, the existing row will be updated based on the new values. One crucial difference between add category and edit category HTML is that we need to add two hidden input fields to hold the value of ID and create a timestamp from the model attribute in the HTML. In our JPA entity, ID can be unassigned for creation since we have marked the field as generated value annotation. But it cannot be unassigned for updation. If the ID is not provided, the record will be treated as a new record and the ID will be auto-generated. Also, created timestamp was annotated as creation timestamp, which assigns the current date time only during creation, and hence we need to assign the existing value we fetched from the database to the created timestamp field in the form. Last updated timestamp will be auto-updated with the current date time during the DB transaction, even if unassigned, since we annotated it as update timestamp. In the same manner, create the edit question request mapping method with request param as question ID, and to the model, we will add the attribute QN, whose value is the question answers JPA entity, which we fetch from the database using findById method of question answers JPA repository. Also, we will add to the model the list of category entities as categories, which we can fetch from the DB using the fetch all categories method of question bank service. This list is used to populate the dropdown. The edit question HTML is similar to the add question HTML, except that the form will be pre-populated using the model attributes we injected to this view using the edit question method. Similar to the edit category HTML, we will add the ID and create a timestamp as hidden inputs. The form posts to the path /question/save, which is already implemented. Let's run the application. In the show all categories page, the table has a column with edit and delete icons for each row. Let's click on the delete icon and a confirmation alert pops up. Press OK. We can see the row has gotten deleted. Let's edit a category. We can see in the edit page that the input fields are pre-populated. Let's rename GK as general knowledge and click update. We can see the table is updated with the new value. Let's check the question answers page. You can see the updated category name in this table. Try to edit a question. The row got updated. Let's try to delete a question. That works fine as well. We have now implemented the capability to add, delete, and remove categories or question answers from our front-end interface. We can enhance the accessibility of data in HTML tables multifold with the help of Datatables, a table enhancing plugin to the jQuery JavaScript library, which provides features like sorting, pagination, instant search, etc. To use Datatables, all we need to do is include the Datatables Bootstrap CSS and JavaScript files to our HTML. Add the Datatables Bootstrap CSS style sheet to the head of the HTML and add the following JavaScript files to the bottom of the body. Provide an ID to the HTML table to which you want to apply the Datatable plugin. To initialize the table, add the following JavaScript snippet to your HTML. Let's run the application and refresh the page. The HTML table is now a data table where we can do instant search using text from any of the columns. We can sort any column. The table is paginated, and we can also customize the number of rows we can view in a single page. We will push these latest changes to our Heroku remote application that we have been using in the past 2 videos by committing and pushing to Heroku remote. Check if the application has started using the command Heroku logs --tail. Use Heroku open command to open the remote application in the browser. The remote application reflects the newly committed change as expected. That's it for this video, and in the next video, we will see how to secure this application using Spring Security by adding a login page, and how to authorize users based on their roles, and how to add single sign-on feature in our Spring Boot application. The GitHub link is provided in the description below. You can check out each lesson by choosing the appropriate branch. Thanks for watching, and we'll see you in the next video.